Hello, we're going to go with the chapter 1. It's the scientific method. I'm going to give you the outline and main ideas of the chapter 1. We're going to talk about what do the scientists do and what's the process of scientists and the importance of the solar system and who were the scientists who started giving us the new scope for this solar system and the importance of measurement in science and who are the ones who started these things and Newton's contribution and understanding the universal gravitation. So let's start with the science in general. The most important thing about the science is what is science? Science is a process. It's really just the way of asking and answering questions about the physical universe. It's always an ongoing process. It's never ending. We always ask the previous known facts and try to get something better answer for that. So that's why we say that it's an ongoing process because we always look for something better in future. Science is not just a fact collection. You cannot possibly write down what science is in a book, but science is something you do. There are two kinds of sciences. We either study the living things or non-living things. For example, living things means life science. It could be something like biology, geology. So we do the research on the living things. The other one is the non-living things, which is physical science. So the example is physics. In either case, the goal is to explore and understand the nature. So we try to understand, look at, and explore and understand it, and we try to mimic the nature to make the lives better. The scientific method. It's an organized approach to discovering the evidence and recording observations. This is introduced in the 16th century. This provides fundamental foundation for the methods of science. What is it? There are many ways to express what the scientific method is. One way is a continuous creative process by which people can learn about the physical universe. So it's a systematic approach of learning a concept or knowing a concept is a scientific method. Basic steps of the scientific method. First, formulate the problem, which is ask a question like example, why the sky is blue? So that's like a question. So we try to research why the sky is blue. And then observation and experiment. So we try to look at the sky, which is observation. Is it blue every day or few days in a week or few days in a month or is all the time? And if possible, we try to do an experiment by doing something which would change the fact that the sky is blue. Interpreting the observations. So whatever the observations you made, based on that, you make an observation, you make a record of your results. You identify the pattern, whether this is blue every day or few days or based on what it is wearing and things like that. And then you test the interpretations. And then you do the further observation. So this is the systematic way of scientists. They follow this template to discover new things. And if the interpretations are not supporting their basic assumption, then they go back and observe and they go back and experiment and then again they interpret and then again they try to draw some conclusions. So this is like a keep on going process until they get the valid results. Important parts of the method. Hypothesis. Hypothesis is an educated guess. that can be tested. So based on some results, we make a guess that this is possible. So probably because of the water, it is having a blue color. So something like that. So we make a educated guess. So that's what is called the hypothesis. Then the next one is theory. The synthesis of a large body of information encompassing well-tested and verified hypotheses from experimental observations. So theory is the tested or validated hypothesis, which is already proven, is called theory. The difference between hypothesis and theory is that hypothesis still has to be tested and theory is already tested. Observation versus experiment. Observation can be done without an actual experiment. An experiment is a careful observation that may require recording quantitative information about the observed phenomenon. An experiment is simply manipulating the nature and then observing the results. Interpretation of observations. This could lead to hypothesis. After observing and experimenting, we may form a hypothesis. So based on the observations, we might guess possibly this is the reason. So it's not completely validated yet, but we just make a guess based on the observations or based on some kind of backup uh, evidence. Hypothesis is often stated as a mathematical expression. Remember, any valid scientific hypothesis must be testable. If it is not testable, it is not going to be called hypothesis. Testing hypothesis. Use the hypothesis to make predictions, so which is guess or expect something out of it. Compare the observations with the predictions. Careful experimentation is the key. Manipulations must be very deliberate. Control is an experiment requires defining variables. So we say that we take one as the base. So that is called the control in the scientific terms. And which is dependent, depends on some circumstances, and it could be independent based on what we are trying to do the experiment. When the evidence is persuasive, natural law, a result of summarizing repeated observations and testing, represents our current best understanding. So whatever the laws we talk about, those are the current best understanding of the concepts. They are subjected to change based on additional observations. Laws of nature cannot be characterized by saying that they will never change. So these are the current best understanding. And if someone comes up and says that, okay, based on these kinds of evidences, based on these tested theories, this is not correct, and then it could be ruled out, and that new law which is tested and verified could be overtaking this law. So these laws are current best understanding, which will have a possibility of changing based on the correct evidences. What is a scientific theory? A natural law tells us what it is. For example, the uh, sun is as the center. All these planets revolve around the sun. So this is the thing which tells you that okay, all the planets follow sun. But theory is something tells you why they follow sun. So that's some examples. Okay, natural law tells you the what it is, and theory explains why it is doing it. And scientific theory is more than a hypothesis or a good idea, or in other words, a fully developed logical structure based on well understood general principles, based on numerous observations and experiments, must be stated in a manner that it will allow it to be tested. These tests define range and limits of theory, may not prove or disapprove the theory. So, a theory is the one which is well tested with the valid logical and limitations of the uh, logical structure. It is really more than just a theory. The power of science is continual. Re-examination of a body of knowledge. As more observations are made, understanding increases. So the laws are something that, based on what the current best understandings. So as they could be changed, they could be improved. There is no set or frozen ideas. So that's why we are saying that no, there could be possibility for change. Science and religion. Both science and religion are a means of searching for order and meaning in our world. Science is something that observe, record, and discover natural phenomenon based on experimental evidence acquired by using rigid scientific method. Skepticism is key. And in contrast to that, religion is a means of understanding the source, purpose, and meaning of our world based on faith, in which we accept many things without any questions. Predictability, a fundamental premise. The universe is but abounds with regular, predictable phenomenon. Key to understanding is open your eyes, ears, in order to observe the world around you. The earliest scientists were astronomers. The birth of modern astronomy. The key players of the astronomy were Nicholas Copernicus, Claudius Ptolemy, Tycho Brahe, and Johannes Kepler, Galileo Galilei. The ideas developed over long periods of time, often with greater controversy, because in the older generations, which is more than 1,000 to 2,000 years ago, the things were completely different from what we have right now. So because earlier years, they were more like religion based rather than the scientific based. So people were thinking differently in olden days compared to what we do right now. Ancient civilizations created myths, legends, to explain what they observed in nature. They observed and named constellations, stars that appear to be closely spaced and whose relative positions remain constant. Greeks were the first ones to include science in their explanations. They believed in perfect nature. The universe was spherical and finite for Greeks. Important observations. Polaris, the North Star. It seems to remain stationary as other stars move around the stars. Used as a guide for travelers due to its constancy. Why is it so? If a line is extended outward along the direction of the Earth's rotational axis, Polaris would lie on the line. Planets' motions, the night sky seemed to lag behind the stars. It was difficult to explain. The retrograde motion. Irregularities in motion, retrograde motion, which is sometimes celestial bodies, in particular some planets, appear to reverse their direction of motion. The Greeks could not explain this.